Okay, we've reached the top of the hour and reaching the usual, this is third session on Thursday, and people are slowly trickling in. Give people one last chance to test their microphones before we kick off.
Hi, Jeff. This is Yingzhen. Can you hear me?
Ingjen, we can hear you fine. Thank you.
Thank you.
Okay, Kayer, take it away.
Good morning, good afternoon, good evening, folks. Welcome to the second and the final session of IDR 112. We have a note well here. Please read this carefully. Please note what it means is you're bounded by these rules that are out here and many more that are described in the BCPs. We also have a code of conduct guidelines that we request you to follow both at mic as well as on the Jabber and then any IM messages that you've been doing. Yeah. On the agenda today, we have about 6 presentations. We have a PSAP presentation coming from Agent. We have dynamic capabilities, the draft that has been resurrected by NK. It's actually a working group draft that NK is going to present again. We have a variant of multi-session on a different transport quick that's going to be presented by Yingzhen. There is a draft on 5G computing app metadata that Linda's going to talk about. Hybe is going to talk about revised error handling draft. And finally, we got a new draft at the last minute draft presentation on flow specifications for DevNet that Quan is going to be presenting. So any questions on agenda bashing before we start? Fantastic. Agent?
Yeah, can I slide?
I can move this. I can change the slides for you. Just let me know when.
Okay. Oh, so okay. So I think you can change it. So the motivation of this presentation is we want to the working group last call within the PC working group, but it is related to the IDR. So we want to the IDR expert to also review it. So the solution is based the other two RC. The first is have published describe the scenario and the simulation result for the TE in native IP network. The second published RC describes the architecture for providing the traffic engineering in a native IP network by using the multi-BGP session and PC-based control central control mechanism. So this document just describes the PCAP extension and the procedures to practically build such mechanism, build such architecture. Okay, next slide. Okay, next slide, please.
Sorry, Agent, can I pause you for a second?
Oh, okay.
Thank you.
So,
Agent,
okay.
can I pause you? Agent, can I pause you for a second? Folks, I apologize, but we need someone to take minutes. G, in case we don't get a minute taker, will you please take minutes? G. Okay, thank you, G. Agent, please continue.
Okay, so this is the overall solution. So we just utilize this is the solution is based on the central controller. So we also want to utilize the traditional BGP session. So there are main 3 steps to accomplish the task. The first is we want to we should build the dual or multi BGP session between edge router upon the request from the PCP. The overall aim of the solution is to differentiate the traffic between two ends. So the first step is build the several BGP sessions between the edge router upon the request, and the second is advertise different prefix via the different BGP session with the PCAP message. The third is we should steer traffic towards the particular route by the BGP next hop with the PCAP message. Okay, next. So here is the detailed procedure for the 3-step. If we want to different the traffic between the R1 and the R7, so we should first build for example, 2 BGP sessions between the R1 and R7, and the to authorize we just download the BGP peer information object. That is BPI from the PCE to let the R1 and R7 build the 2 BGP session. The main information within this object is the PRS number and the local peer address and the tunnel source destination address. This is similar with the normal BGP session setup requirement. Okay, next slide. So after the BGP session, multi BGP session being established, we can let the border edge router to advertise the different prefix via the different BGP session. So we should send the explicit peer route object. This is not no. The second step is the second step is we should explicitly point out the path from the path to the BGP next hop from R1 to R7. So we should send the explicit peer route object from the PCE to the edge to the router on the forwarding path. For example, R1, R6, R8, R5. Okay, and the main information included in the object are the route priority and the peer tunnel destination address and the next hop to the peer tunnel destination address or destination address. Okay, next slide. Next slide, please. Okay, yeah. The third step is because we have built the different BGP sessions between the edge router. We should let the edge router advertise the different prefix from within the different BGP session. So we should send the peer prefix advertisement object to the edge router. The aim of such object is just as I described, is just to let the edge router advertise the different prefix to its peer via the different BGP session. So based on these 3 steps, every router will receive this prefix, but the next hop to this prefix has been changed by the by the second step. So the overall forwarding path on the router will be also changed. So that is the final result is the normal traffic and the priority traffic will be forwarded on a different path. So this so we can achieve the different QoS requirement. Okay, this is the overall solution. Next slide, please. Yeah. So the information transferred in this shaft is mainly used for the first is the lightweight BGP session setup. The second is the explicit route deployment. This explicit route is to the BGP next hop, not to the prefix. So it can reduce the burden on the internal router. And the third is the prefix distribution by the PCAP. So and the planning, allocation, and the distribution of the peer address within IGP domain should be done in advance. Okay, next slide. So we want to ask the expert within IDR for the overall solution that use lightweight BGP session and we are also prepared for the working group last call, both in the IDR and the PC working group. Thank you.
Thank you, Agent. Any questions for Agent? So Jeff, this is yet another draft that will need a collaboration between PC working group as well as IDR, I believe.
Yeah.
Absolutely. So what we should be doing is we'll add this to the wiki of things that need to be tracked across working groups. And additionally, we'll try to find a time for working group last call to be shared across IDR and get chair review as well. And we'll try to get you some form of deadline, likely the week after IETF.
Okay. I also welcome any comment within IDR mail list for the for the question. Okay.
Folks,
I think this slide need not be. Oh, should I introduce it? This slide. This is just for the backup usage.
Cool. Any questions for Agent, folks? Thank you, Agent.
Okay.
The next speaker is Donald for flow specification version 2.
Hi, this is Donald. Sue Harris is not available due to some medical problems, so I'm just going to give a very brief presentation about what's going on with the BGP Flow Spec version 2. Next slide, please. So just an introduction for people who haven't seen this, most people I'm sure have. Flow Spec is about the distribution of filters, that is to say packet match criterion and resulting actions. It's about the number of existing applications, and the initial motivating application was DOS mitigation, but it's been used for other things as well. And there exists a Flow Spec version 1 defined in RFCs listed on this slide and some working group drafts. And the idea is that future efforts would be directed to version 2 because of the problems that have been found in Flow Spec version 1. There's no consistent TLV encoding, so extensibility is difficult because you can't skip over things you don't know the type of, because there's no consistent length encoding. There's difficulties in it. There's no user way in general to specify the order for the application of filters or actions. In case you have different peers who have different levels of support for Flow Spec, currently either supporting or not supporting FSV1, and I guess in the future supporting or not supporting FSV1 or FSV2 or both. Those peers with these different levels of support interact wasn't specified. So FSV2 intended to solve these problems, and it uses new SAFEs to keep itself separated from FSV1. Next slide, please. So there's a version 3 draft is posted. I'd like to welcome 2 more authors to this draft, Chaitanya and Sven. And this is a considerable expansion to the 02 draft. The draft is becoming somewhat more mature, but I don't think it's mature yet. That went from 22 to 57 pages. That's just the body text, ignoring the references section. There's more and improved material in almost all the sections, particularly material related to ordering, including ordering between the rules received via FSV1 and FSV2. More control over the way that failures are treated in a chain of actions that are applicable to the same particular filter. Some more material expanded on how validation, both against routing, determine whether some FS should be ignored or put into effect, and also cryptographic validation. And there's now a section on manageability. There's really lots of changes here. But I decided a brief report would probably be appropriate in this case, and hopefully this report will be short enough that more time will be available for other items at this IDR meeting. Next slide. So there is work progressing on a more mature version 4 draft. Any comments on the version 3 draft would be welcome. A lot of comments were received, and they're included in the being included in the version 4 draft to the extent that we can. And there is a IDR virtual meeting scheduled for 13 December, which on the tentative agenda as sent out includes the topic of FlowSpec v2. So I would think that would be a good place to think that we will be talking about all of this in much more detail. So that is my effectively a status report on FSV2. I'm welcome to have any questions people would like to ask, and I'll see if I can answer them.
Thanks, Donald. This is a pretty serious work that's coming up. It's very comprehensive, so we do urge both the operator community as well as the developers to take a closer look at this and provide as many comments as they can upfront to Donald and other co-authors. Questions for Donald?
Okay.
Thank you, Donald. Thank you so much. The next on the list is dynamic capabilities for BGP. This has been a working group draft for a while. It's been back with updates. NK is going to talk about it. NK?
Hi, Gil. Hi, everybody. Can you hear me?
We can hear you.
Thank you.
Okay. All right. This is Anchor Chen from Palo Alto Networks, and the co-author is Srihari from Juniper. Next slide, please. So this, as Q just mentioned, this document has been there for a while, actually for a number of years. Version 14. I think there are several reasons that draft has not been refreshed before, because we felt one reason was that we felt that the spec was stable, and actually it's really waiting for the implementations. So we have to apologize. We got lazy, didn't do the necessary work to refresh it. So we have been made aware that there have been multiple implementations over the years. The capabilities are being supported at the address families and also the GR. There are certainly I think the multiple implementation on the GR. That was it's if you look at the original motivation was really for enabling disabled address families for provisioning, and this later the GR came in, the support came in, and to dynamically revise the timers for the GR in the case of plant maintenance. So over the last couple of years, we received the authors received a couple comments from implementers on the draft, and so it is that's the reason for the recent update. Next slide, please. So we decide to post two versions of the draft. The first version is really because it has been a number of years and there has been a lot of changing in the template. So the version 15 is all about template changes. So that way we can minimize the basically protocol changes or clarification in the version 16. So this update is really about the 16. So in version 16, here are the changes. One area is the clarification on the multiple instance capability. So this clarifies that for such capability, each instance should be revised individually. Currently, really, only the address family belongs to this category. I think it's really for historical reasons, because the capability length is defined as 4 bytes. It's not instead of multiples of 4 bytes. That's why if you look at this, the capability advertisement in the open is really listed individually. The AFI, sub AFI, these are in 4 bytes field, and instead of the TLVs. Right, so this makes it very difficult. If you look at multi-protocols later, it clarified, it actually spent quite a bit of text on this, talking about this multiple instance. It's mostly historical. We have to deal with that because the length is 4 bytes. It's not in multiples 4 bytes. And also this, because now to further clarify, because if we have to talk about multiple instance capabilities, then we also have to talk about single instance capabilities. So we clarify that for the single instance capabilities, basically, this whole capability is revised. Because there's only one instance, right? Every time you add, you want to modify one field, for example, timer, you have to advertise the whole thing. Right, it's a replacement of the whole capability as a whole, right? And also there's a one clarification is basically how do you remove this single instance capability? What will be the length? Because the capability you have the type, you have length, you have the value. So this here we clarify. Although this is, I think that's what people have been doing. It's basically when you remove a capability, the length field should be set to 0. Next slide, please. So I think several people also suggested, have a question about, what capability to support. If you look at the spec, starting from version 5, basically the protocol extensions is generic. It's really not limited to specific capabilities. There's enough protocol machinery to deal with the capability changes. It's generically. So we feel that basically what capability support will be decided by the implementers and by the customers, basically. And so this here we add a section as suggested by several people, I think including John Scudder and Jeff. Basically, we say we should be selective on the capability that to be supported, because due to the complexities that might be involved for some of the for some of the capabilities. Clearly, not all capability are equal, right? Some are simple, some are more complex. So there are trade-offs. So it's hard to say, okay, what probability should be supported or should not be supported. As an example, when we started, right, we didn't think of GR would come into play, right? It's something that needs to be revised dynamically. And especially in the future, if new capabilities will likely be introduced. So it's we feel that it's difficult, and it's also not necessary to basically to exclude the support of certain capability. I mean, that basically is left to the implementation and to the market. Next slide, please. So here are the next steps. So just last week, I think the INI basically did a review on the version 16, and also GF did a detailed review. So there were a couple issues actually identified. One is the capability message type. This basically is it's defined as a 6. That would remain. There's no need to change that. That's good news. But as the IANA editor basically recommended, we should not say it's defined as a 6. Instead, we will say suggested value is 6. And also the GF's part is this one. The error code actually conflicts with the error code allocated for extended enhanced run refresh capability. I think the reason is that because this draft has been there for a long time, the other draft basically got ahead of this one. And I think this draft, as I recall, we didn't. I think we didn't have a rigorous procedure for early allocation years ago, and so it's just we just sequentially putting a number there, and that is causing problem. And the new value will need to be allocated. We will need to work with the chairs to get the early allocation so that the existing implementations can make the necessary changes. So we certainly welcome the reviews, and especially in particular the experience from implementers. And we also we work with our chairs on the implementation report. So folks, if you have an implementation, please let the chairs add all chairs add /o the mailing list know about your implementation. In particular, which capabilities you support, right? And also, I think last couple of days, I think there's one more thing I think we would like to do, given the long history of this document, and especially the significant changes from version 4 to version 5. I think we would like to add appendix to the document to make it clear what has changed or the evolution of the draft. That will help the implementation and also interoperability in the field. And I would think that's optional. That should be removed, before final publication. All right, I think these are all the slides we have.
Cool. Thank you, Anchor. AC?
Thank you.
AC got a mic.
Systems. You can hear me, right? AC Lindum Cisco Systems. So I agree that it shouldn't be for, it should only be for capabilities it makes sense for, but that's not going to be specified. So what happens is if people support this dynamic capabilities, but they don't support the same set of capabilities, the session just gets reset if there's a mismatch, right?
No, actually,
operationally, you'd have to document what you
No,
support.
AC. Let me reply, AC. It's actually that's not the case. You basically this is by negotiation. Up front, you say, okay, I support. Let's say A says I support A and B, and AC you say, okay, you support B and C. So in the end, we can only do B. We cannot do A and C. So you basically it's controlled by both sides. Both sides have agreed to support a particular capability, then the dynamic revision can happen.
Okay, so
yeah,
what would
that
happen
part is clear in the spec.
So what would happen is you would attempt a dynamic renegotiation, and if somebody supported A, B, and C, then the other guy supported C, but the other guy didn't support C dynamically, it couldn't be renegotiated because he doesn't support that dynamically.
So basically, up front in the open message, you have to list what you support. Right, that cannot change.
So I'm talking about the dynamics.
Dynamic is the second step. So in the open message, one side say I support dynamic revision of ABC. The other side they say I support dynamic revision of C. Now you can only do C, dynamic revision of C, because both sides support it. You cannot do A and B.
Okay. I didn't reread the draft. I haven't read it for a couple of years. Thanks.
Yeah. So that is I think that is. Remember, for folks who still follow the draft, originally it was too broad. We basically say, oh, I support dynamic capability. Turns out that's very problematic because it means, I think the semantic is not clear. It means support one or two or all of them. So I think before version 4, even we say, okay, now you have to list what do you support up front, right? So there's basically, if you look at protocol extension, right? One is a definition of the basically it's you advertise your the dynamic capability in the open. You list the capability you support. Then the second thing is the message, dynamic capability message for revisions subsequently.
Cool. Thanks, Jeff.
Thanks. So I think you've answered part of the question, which was how do we know what's safe to change? You're saying the procedure has been limited to only allow us to update things that we have originally exchanged. I still think there's probably edge cases in that where, let's pick add paths as an example. That's not safe for you to renegotiate. So it'd be nice if we had a way, maybe a parallel capability that said, here are the capabilities we allow to be renegotiated. So take that piece as a standalone bit of feedback, but certainly having it is renegotiate only the stuff that is inside of the open message simplifies procedures quite a bit versus what was there some years ago.
Yeah, that also gives the control to both sides. So it's basically there are multiple controls. One is the software capability, right? Your implementation. Basically, we don't expect vendors to implement the capability that does not make sense for dynamic revision or that involve too much complexity. That's one level of control. If the software does not have the feature, you cannot use it, right? Second thing is that it's also operationally, once the software supports this, the revision of particular capability, it is either side can decide, do you really want to enable it by configuration, right? Operationally. So so they are this, yeah.
Right. So again, there may be situations where a implementation A had negotiated a feature with implementation B. You want to revise it, but it may not be safe and the session would drop. Knowing if it's going to be something that could cause it to drop, if A knew that, it would potentially avoid trying to renegotiate and simply bring it to operator attention. Anyway, so that's the feedback on the procedure. In terms of advancing the draft, you're saying that there's multiple implementations, meaning greater than one. If these are actually multiple independent implementations, we have a lot of easier opportunity at IANA to move things forward in terms of early allocation. So if you could take the link that's in chat for the wiki where we'd like to get the implementation report filed, this would let us do this very, very quickly.
Sure. So it's here. I think the last time Sri Hari and were discussing this, we are not sure about the procedures of doing the implementation report. So we will work with you, with the chairs, with you on that to see. Because there are some implementation are public, they basically is in their online documentation. Some it's not clear, but through the emails, through the question, we know that there are other implementations as well.
Okay, that was my questions. Thank you.
Super.
Thank you.
Thanks. Hey, NK, one comment as a working group member here, K. Patel Arcus. The draft has been around for a while. I'm personally happy to see implementations. You've talked about what capabilities can be negotiated, and the kind of capabilities can be negotiated is upon implementers and upon operators to decide in the field. What would be cool is if you can make a comment or two, and you can take this to working group as well, as what are the easiest use cases to enable this draft for? I think AFI-SAFIs are the low-hanging fruits, but something like that to say, hey, you can enable this, and by the way, the easiest use cases when you want to enable a new AFI-SAFI. Something along that lines, I think will also allow more implementers to think about where the feature can be enabled in a limited use.
Yeah. Actually, if you look at the version 16, right, in the introduction, we also added text on GR. Because primarily these two things certainly make sense. The AFI-SAFI and plus and the GR. So if we can look at it. If you can offer some text, that would be cool too. So we will look at it.
Super. Thank you so much.
Yeah. Thank you.
Any other questions for NK? Thank you, NK.
Thank you.
Next is multi-session for BGP over quick. Yingzhen.
Hello, everyone. This is Yingzhen. I'm going to present use of streams in BGP over quick on behalf of the co-authors. Next slide, please. So first of all, why do we need BGP multi-sessions? Most of today's BGP implementation support only one TCP session, and all supported AFI-SAFIs run in this one connection. There was a draft IETF BGP multi-session several years back proposed to support BGP multi-sessions. As pointed out by the draft, there are two major issues. The first one is that most malformed messages cause the TCP session to be terminated. While this might be necessary for protocol correctness, it is desirable that only AFI-SAFI with the malformed message to be terminated and leave all other sessions untouched. For example, a malformed message or even misconfiguration in flow spec should not impact the regular IPv4 or IPv6 address family. The second issue is that since all these AFI-SAFIs are carried in one connection, and as BGP is extended to carry more and more services, there are more chances of control plane resource contention. If we can separate all these services, it's easier to manage such contention. Next slide, please. So, Quick, defined in RFC 9000, is a UDP-based multiplexed and secure transport protocol So I'm not going to talk details about QUIC. Just want to mention that QUIC exchange information via streams. A QUIC connection can carry multiple streams. As shown in the picture here, in a QUIC packet, multiple streams can be multiplexed into one packet. So each QUIC stream has its own flow control, as well as flow control for the entire connection. Next slide, please. There was a draft presented at last IETF which defined the mechanism of using BGP over QUIC. So this draft builds on top of that draft, specify how to use QUIC streams to establish multiple BGP sessions. Each BGP session operates independently, which means if there are some critical condition happens in one session, it won't affect other sessions. So we have a picture here on the slide trying to illustrate the idea and the difference. Most implementations today run all the RFC-SAFIs in one TCP connection, which means packets for different network layer services are carried in one TCP connection. While in QUIC, we can use one stream for one RFC-SAFI, as shown in this picture. It works like you have multiple small pipes inside one big pipe. Next slide, please.
Yingzhen, I'm sorry to interrupt. Linda has a question. I just want to ask Linda, are you okay to wait till...
I just have a very quick question for clarification. So are you talking about multiple sessions between same two nodes?
Multiple BGP sessions between a peer.
Oh, okay. Why? Oh, sorry, you can go on.
Yeah, maybe you can ask the follow-up questions after the presentation is done. That would be perfect.
Okay.
Thank you.
Thank you.
Thank you, Linda.
Next slide, please. So here are some details. The BGP multi-stream capability is defined to indicate that a BGP speaker can support multi-sessions. Once a BGP session is established, it follows the regular procedure as specified in RFC 4271. So we have a figure here, just it's a snapshot of the encoding of this MSC. Next slide, please. Oops.
The user interface for page flip is too close to the close button.
Yep, that's what happened. Sorry for that.
No problem. Next slide, please. So error handling. This draft introduces a few new error subcode in open messages about multi-session conflict, session capability mismatch, network layer protocol mismatch. So I'm now going to read the slide. If you want to know the details, please read the draft. Next slide, please. So collision avoidance. Before creating a new session, a BGP speaker should check that no session exists for the same network layer protocol. If a session already exists, the BGP speaker should not attempt to create a new one. In case of a collision happens, it's resolved using the extension specified in RFC 6286. And please refer to the draft of details. It's sort of long. So Next slide, please. Next step, we are going to continue to refine the draft, and review and comments are welcome. Collaborators are welcome. And that's it.
Cool. Thank you, Yingzhen. Sorry about that.
Thank you.
Linda, do you want to go first? There are a bunch of questions on the chat as well.
So I'm curious about this multiple sessions, right? You mentioned IPv4, IPv6. So I always thought the BGP over TCP, the TCP session just maintain that they can have retransmission in case some packets get lost. And then in terms of indicating different capability or different the prefix, whatever, is already reflected by the IPsAPI. So one BGP speaker can advertise multiple updates with different IPsAPIs. So indicate different things. So why you need different sessions? To me, it's practically achieve the different purpose of different packets already.
So as there is one slide. Can you try to go back to slide, I think number 3, maybe?
Number 3 or number 6?
Yeah. So there is the one that has. So like you have all RFC that carried in one TCP session, right? So something wrong in one RFC will cause the entire TCP session to reset.
What do you
That's
mean
the
wrong?
major.
What do you mean wrong? You mean packet get lost?
Now packet get lost. There are different error conditions that's defined by the protocol. For different address family, there might be different error conditions. All those error code, a lot of them will cause session to reset. So just like the example I used, you have something wrong in flow spec, that will cause your entire TCP session to be terminated.
So that's really up to the implementer, right? The implementation, right? The router A may reset the BGP session.
It's defined in the protocol. You have to reset the session.
Okay, I'm sure there'll be reasons why you need to reset. So the same reasons can cause your session to be reset as well, does it? I'm just curious on that.
Yeah, these are great questions. We should take it on the working list in the interest of time. But I think Linda Yingzhen is talking about is if there are errors which are specific to address family, that will cause the entire session to reset and affect other address families.
Right. Yeah.
Thank you.
Thank you, Andrew.
Can you guys hear me? Okay.
Yeah.
Yes, I can hear you.
My question here would be, if we've got a problem with the session resets, as you say, would this not be better served by a simple modification or BGP itself to allow AFI-SAFI resets rather than the entire session reset, rather than kind of reinventing the whole underlay to BGP in this manner?
Yeah, so I think that was the point of the BGP multi-session draft, right? What it was trying to do is to support BGP multi-session over TCP. Right, so you something wrong in one RFC, you don't want to reset the whole connection. That cause all the IPv4, IPv6, whatever carrier there, all reset. So the difficult part with that draft is because you have to use TCP and then you need to have multiple TCP connections. Not like what we are proposing here, you only have one quick connection and you can use streams to support RFC. So you can have these virtual pipes. Hope I explained that clearly. Did I answer your question?
Thank you. NK?
Yeah. Can you hear me?
Yes.
Okay. So just to clarify on the error handling. So if you look at multi-protocol extensions, it basically sort of generically mention that if this error is associated with a particular address family, basically this address family can be disabled. But then the error handling spec basically carry that forward. Basically, as one of the actions, short of station reset, you basically disable that. But that has not been really spelled out completely, and has not been. I'm not aware of the implementations actually doing that. But I'm just thinking that because we have that spec for error handling to disable a particular address family, coupled with the dynamic capability that actually can be achieved now. Dynamic capability for address family to enable or disable. Let's say in case of an error that's associated with a particular address family, then you basically disable that temporarily. Later, if you can also enable it. That part was missing without dynamic capability. How do you actually re-enable a particular address family?
Yeah.
So it's
thank you
it's
for
not
the.
it's certainly I agree. It's not as clean, I think, as you have a complete separate sort of station concept.
Yeah, thank you for the clarification. I didn't know that you refreshed the dynamic capability draft. So that has actually a big impact for us. I will look into the details of your draft and see whether what impact it may have, and we can talk
Yeah, you
offline.
can also look at this. Look at the error handling spec, because this is one of the actions, basically short of session reset. Is to
So once we support.
Family.
Yeah, I agree with you. Once we support dynamic capability, a lot of the cases that may not cause the session to reset, right? So you add a new address family, configure a new RFC, that sort of thing. Yeah, that's actually a big improvement.
Thank you.
Thank you.
Thank you. Jeff?
Yeah, just to add a detail here, one of the problems that the error handling draft was attempting to deal with is that when NLRI in particular are malformed, we sort of lose where the packet boundaries can be, since this is all in a TCP stream. It's my belief, I need to finish reviewing the Quick specs, that Quick provides a proper layer 5 style session, and if that's the case, this means we have some additional alternatives about how BGP can handle some of these error conditions. So places where we had to reset the session because we couldn't trust the packet boundaries potentially go away. It still doesn't handle our issues with malformed NLRI, not letting us know what the actual prefixes are, but it moves us from having to reset the session immediately to moving to potentially not trusting the session.
Yeah, thank you for that point. That's exactly what we are trying. One of the reasons we are trying to do here, right? So you have a malformed message in one particular RFC. We want to just reset that session instead of the whole entire connection. Any more questions? I see there are a lot of comments in the chat window. I will try to catch up those comments, and we will communicate more on the list. Thank you.
Thank you, Yingzhen. Next up is Linda with 5GH Computing.
Okay. And okay, so this is the update to the BGP update to reflect the 5G edge computing service related metadata. Next slide, please. Okay, so just to recap, so in the 5G edge computing environment for low latency services, they may put many servers in close proximity to serve the same application. And I know that still there are people debating that those kind of choosing the right server should be application layer function. It is true that is all done today. And so for the application layer to choose the appropriate server, they normally use local DNS. So practically making the local DNS being the one managing the traffic condition. Basically, based on their load, and they can give different address to the ingress router. And so the ingress router resolve the new IP address, it will go to the new server. However, this kind of approach using the local DNS as a traffic manager, it doesn't take into consideration of the actual traffic condition in the network. As you can see that all those routers in there, they may experience stress or they may experience actual load. So this draft is to bring some of those attributes to be propagated to the ingress router so that they can build appropriate tunnel to the specific egress router. So here's an assumption for this draft. We're talking about small IP network close to the 5G core, and the services which need those low latency services are limited. Just like today in like AWS Wavelength Zoom, you have to register your service in order to receive the low latency service. So we're talking about limited number of addresses. So with Anycast address, like say for example S1 here being attached to 4 different egress routers, if they are assigned as the same address to the ingress router, they are just saying multiple next hop to reach that same destination. We want to be able to advertise the associate cost for this S1, like associated to different egress router to the ingress one, so they can compute the right path. Next page, please. So we made some major changes to simplify the attachment. The site cost is now associated with the tunneling cap. So basically, for the egress router to announce a particular prefix can be carried by certain type of tunnels. It can also attach the additional cost to reach this prefix, so that for the ingress router, they can compute that, okay, to reach specific prefix, I can use this specific tunnel, and this tunnel has this cost. Of course, we have some assumption there that the matrix change, the frequency of the changing of those matrix has to be large enough to not cause too much oscillation in changing the tunnel selection for the ingress router. In the NANOC talk, a couple of NANOCs ago, there was a talk about how they, in the wireless domain, how do they manage the Anycast servers. Actually, there's some issue. They're talking about when traffic pattern change, it takes months for them to install new servers in new locations. Like for example, there was a talk about before pandemic, there used to be traffic mainly centralized in certain locations, but during the pandemic, it's shifted to different locations, naming data centers. So here, if we can change the timer to be in matter of hours or days, then we can help the applications to be better balanced, utilize our network condition. So basically here are some of the sub-TLVs we propose that can be attached to the tunnel in-cap path attributes. Okay, Next slide, please. So another thing is, since the number of those services are very limited, not every router is interested in those services. So we can use the route constraint distribution so that those attributes, those matrix are not flooded to everywhere. Especially, for example, like we can have a table like based on application server ID, and indicating what kind of ingress routers might be interested for this kind of service. Okay, next one. Okay, so this is just, I think, second time we presented here. We want to get more feedback. And okay, that's it. Questions?
Jeffrey? Thank you, Linda. Not sure if my voice is audible, but Jeffrey, do you want to go? Jeffrey, you are in the queue. We can't hear you if you're talking.
How about now?
Much better, thank you.
Okay. So earlier I sent the email to LSR and IDR and 6-man list talking about basically referring to a discussion from in the springtime about the use case. There are actually two problems to solve in this use case. One is how to pick which server to use, and the other one is how do you stick to the same server when mobile devices move to a different anchoring UPF. The second problem is actually harder to solve, and the long email discussion in the 6-man list in the springtime explains some complexities there. So based on all that, I believe, and actually many, according to that Linda agrees as well, that the best solution to the problem is actually at the application layer. Just use an app server, app load balancer to pick which server to use and to make sure the traffic sticks to the same server when the UE moves. So just want to mention that there is an email thread about this. Thank you.
Yes, thank you. I agree with you. Many people working in cloud provider, like my sister included, she worked for AWS layer 4 load balancer. She debate with me all the time. Basically, from their perspective, that network doesn't need to do anything. Application layer can take over everything. However, their approach have their limitations as well. They can instantiate a load balancer very quickly. However, the load balancers they instantiate is at their specific location. For example, when they deploy those wavelength zone in service, like in Verizon's edge data centers, now like AWS has wavelength zone instantiating Verizon's local, they call access point data center, SAS, SAP or SAS. Anyway, they cannot really add a server, load balancer that easily. It takes months for them to be able to add a new server there. So they can do a lot of things, but I think networking, since we are the underlay provider, and we have lots of information that can help them make their service better balanced. It's not that everybody going to take this approach, but by having an approach there on the table, eventually they will see that, hey, actually, this is better than what we have done. So that's why we propose this approach.
Right. But the thing is that solving which server to pick initially is just a small part of the solution. And when the UE moves, how do you make sure you stick to the same server? That's a more complicated problem. That's why when you consider all those problems to solve, you may still agree that you may agree that the best solution is still at the solve it at the application layer.
Okay, so that's in the 6 months discussion, and we can continue there because we didn't get a chance to present there for the solution. How do we do the sticky service? For the sticky service, and especially in a 5G environment, when UE moves, the source address don't move, okay? And also the flow ID don't move. So based on those information, especially BGP, they can cap it into the same tunnel to go to the previous egress router. That is not hard. Actually, today's router, modern router, can support that feature. It's almost like traffic engineering. When you have bandwidth change, when you have path condition change, and how do you swing from one path to another path, the cost changes, right? It's same problem, same solution. We have done that for many years.
Yeah, I actually have a question, but we can take it offline about the UE address change. I have some doubt there, but we can take it offline.
Okay, thank you.
Thank you. I've got a quick question for you as a working group member, Linda. This is Keyur from Arcus. Linda, can you comment on the chattiness that this would bring in, or you think this won't make BGP any more chatty than what it is?
It shouldn't, as long as we put a timer there. It's not like every minute you change. We're talking about hours or days, the frequency granularity. So I think we're going to modify the draft to reflect that. We're not making, we have to set a timer for the matrix change.
Okay, super. Thank you, Linda.
Thank you.
Next we have is Haibo for revised error handling for BGP messages.
Hello, everyone. Can you hear me?
Yes, we can hear you.
Okay. Now, hello, this is Haibo from Huawei. Our topic is about revised error handling for BGP messages. Next slide, please. Here is a simple scenario for BGP error handling. Suppose there are three routers, router 1 to router 3. They are connected to the RR. Then the R3 may update some message to the RR. When the RR found that the packet has an error, the RR will reset the connection. Later, the session will re-establish. Then the R3 will continue advertise the message. The session will go down and up again and again. This may occur for each session. Such a procedure don't help to solve the problem. Why this occurred? Perhaps R3 may have some software bugs or inconsistent understanding of standards. We will also have met this scenario in some interconnection with other vendors. Yeah. This procedure is defined in RFC 4271, but it's too strict. And also it was revised by RFC 7606. But there are still some not clearly description of the situation. Next slide, please. This is our proposal. Our proposal is to reduce the impact of these errors on BP existing services. As this current procedure doesn't help to solve the problem, we want to decry some scenarios where the current definition is not clear enough and some are too strict. The following is something about the suggestions. First, about the MP rich and MP unrich. Yeah, there are there are three kinds of sub scenarios. The first is the prefix length error. Now in current procedure, when we find prefix length error, we also may reset the session. So we recommended that we may discard the error prefix and stop the current message passing. but we also may keep the correct prefix passed before. The second is that when the message there appears more than one MP rich or MP unrich attributes. In this scenario, we recommended that we may process with the last one or the first one and ignore the others. The third is that the net hop length error. Also, for this scenario, we recommended that we may ignore current message. The second is about the validation of the address. There are two sub-scenarios. The first is that the address is indicate the BP's ID. The RFC 6286 they define the BP ID is only unsigned integer. Only 0 is invalid. All the other values is a valid BP ID. Then there are some attributes such as aggregator, AS4 aggregator oriented ID, and class list. These attributes are all use the number as the BP ID. So we may clearly define that only the 0 value is invalid. All the others are valid. Another is that address indicates the IP. Many use the nethop attribute. In most cases, you can assume that valid unicast address can be used. So the multicast address, reserved address, and broadcast address, and some invalid address shouldn't be used. Also, there are some special address such as all zero. Also, we shouldn't use this either. But also there are perhaps some other special address such as localhost address. This is whether we should use it or not. This is a service behavior, so we may not focus on it here. The third is that about the prefixed attribute. This was introduced from the RFC 8669. This was defined to create a SR tunnel, BP SR tunnel. When we find the attribute is incorrect, it means that we can't use it to create SR tunnel. So we may withdraw the rows because it's otherwise it may cause some unexpected result. Next slide, please. Also, before this meeting, we have received some comments. First, we thanks for the Robert's comments. He gave us many comments. Some comments we have been described in the previous discussion. There are also some general comments for discussion. The first one is whether we may issue it RFC 7606 bits or separate draft. We think that we may first discuss which problem scenarios need to be modified, and then we may discuss about whether to do a bit or a new draft. Yeah, the second comment is that BG4 protocol running on TCP is not bulletproof when it comes to handling bad implementation or malicious protocol attacks. Consider using new transport which no longer runs on TCP and essentially not only treats all surfaces as fully independent streams, but also cuts interdependency between the all NI, even with given surface. We may suggest that we may consider polishing the existing BP mechanism, and also then we may also consider improving the BP protocol mechanism, because now there are some drafts such as Engine has showed before the BGP multi-stream over user quick, also and some RFC like BP multi-session. So we may consider that, but we may firstly consider polishing the existing BP mechanism. Next slide, please. Yeah, okay. We welcome. We also welcome more comments and discussion. I also I just see that this afternoon I have received some comments from Anchor. Yeah, but we don't have time to reply for it. Thank you.
Thank you. Anke? Thank you so much. Not sure if I'm audible, but Anke, can you hear me? You can go first.
We can hear you, Kairi.
Anke, we can't hear you.
Yeah, can you now?
Yes.
Can you hear me?
Yeah.
Okay. Could you go back to the slide that list the several that itemize the issues?
This one?
Yeah, this one. Okay. So I reply on the mailing list. I think mostly I agree with Robert's comments, but I think I have several more specific comments. One is this. Regarding this NLRII, basically passing, if there's any error, if you look at the IFC, the base spec 4271, basically there's a semantics validation, right? So basically, this NLRI passing, if you have an error, this will be basically it belongs to that category, semantic validation. And the fundamental to this enhanced error handling is basically previously, as you correctly stated, the base specs basically say if there's any error with a prefix, you reset the session. So in this, in the enhanced error handling, what we stated is that basically in some cases you can use treat as withdraw. So you keep the good guys and throw out the bad guys, right? But the fundamental to this mechanism is basically you will be able to pass all the prefix in the NLRI field, or in this NP-rich or unrich NLRI field, all of them. That's the fundamental to that enhanced error handling draft, and in particular to the treat as withdraw. Because if you as we all know, BGP update is incremental. Anytime you discard, you ignore a message as you have here, or ignore part of the message, now you may have a stale wrath, because it's incremental. It will not re-advertise to you for a long time, right? So that's fundamental. I think what you are proposing here, this is not correct. The moment you do this, you say, okay, I keep the prefix that passed previously. That's good, but all the prefixes that following that you have not passed correctly, that will become stale. Let's say these are replacement, or they are not reflected. Now it's basically at that point BGP will not behave correctly. So this is I think fundamentally this problem. I have a problem with relaxing the error handling for the prefix semantics validation. And in terms of this, that's number one. In terms of this, the BGP ID in the aggregate or ES4 aggregate, or the original ID. I think at that time we talked about that. We felt that it's unnecessary for us to sort of make it more restrictive. If you look at aggregate, we didn't specify that, okay, 0 is invalid. It doesn't really matter, right? And also the original ID, if it's 0, that's a bug. But how much harm does it cause? If you treat that withdraw now, suddenly you are losing reachability, right? So the cluster list actually, I went back look at reflecting spec. We didn't specify 0 is invalid. So we can, at this stage, we cannot do it, right? I think the only thing from this proposal is really the next hub. Next hub could be interesting. It could be, if necessary, I think there's room for improvement, because the way we have, I personally run into multiple cases of next hub issues. For example, there's a misconfiguration of interface addresses. You have a duplicate, but as the base spec specifies, you have to drop that update if the next hub contains your old address. You cannot even recover. I mean, in the old days, you have to reset, right? So that is certainly that can be improved, right? So that's I think I think if working group agrees, that should be, I think, as a separate document, just focus on the next hop validation, right? Interim prefix SRD, if this I'm not expert in that area. If there's an error, that is certainly that spec was published after enhanced error handling spec, and as expected, that draft should do the proper error handling specification. If there's error there, then the authors of that IFC should issue a BIS revision. That's following in the tradition, right? That's all the comments. I think it's the email has more details. So in summary, I think there's perhaps some benefit to basically to have a targeted, more focused, draft perhaps on this next hop attribute.
Yeah, thank you, Anke. Yeah, you have too many comments, and also I just see your email, but I think I think we may first just some little discussion about this. For the first, about the MP reach. Yeah, for MP reach, that perhaps we see that we may also, when we found the prefix error, also we may keep the correct prefix. This is because in this behavior, we just think perhaps we may do our best effort to process it. But also it because for some stuff is the one message, one update may have some multiple rotor types, such as EVPN. They may have too many kinds of row types. When some rows are updated or packaged in one update message, perhaps we may, for some such as type 1, type 1, it may be correct, but the others such as type 2 or type 3 may be some errors. So in this case, we may keep the type 1 rows and discard the others such as type 2 and type 3. So I think this also may be a situation scenario.
Hebo, I think the key
Yeah.
thing is this: you have to be sure the who field, NLI field, or the MP reach, unreach, all the prefixes are passed correctly and fully. You cannot say, okay, I partially pass this field, then I keep whatever I able to extract or I have able to pass. Because at that point you don't know what is following. Because it's incremental. Keep in mind, BGP is incremental. Okay, so at that time you are not sure. You say, okay, is it better to keep this A, but there's a B and C become stale? I mean, you are not sure, and it's guessing. So I think if you look at the revised error handling spec, that's what the fundamental is really you will be able to, successfully pass the whole field, not partially, right? Once you know all the prefixes, then you have there are ways to handle it more gracefully, right? You can use withdraw. You can use treat as withdraw. You can do that because you know that you get all the prefixes. You are not going to have stale entries. I think that's really fundamental. I think we have to come to agreement on that.
Okay. I think we may consider it for more. Okay, and the other comments I think also is too much. As perhaps I will reply at the mail list. Is it okay?
Yeah, sure.
Okay.
Thank you, Anke. Jeff.
Thank you. So I'm going to very lightly repeat a couple of Anker's points. Some of the things you're identifying in the draft look like they might be small changes to 7606 for some edge cases that might be okay to loosen. Please feel free to push on those as things to be clarified. I agree with Anchor that being able to have easier verification of a next top and decide, if you want to use that as a criteria to avoid bouncing sessions may be also worth discussing. The thing you're going to find, and this is where I put on my working group chair hat, there was considerable discussion about what to do about bad NLRI that took up the majority of our discussion when we were going through the RFC 7606 process. And it's the one thing that is going to be the most difficult to convince people to revise. I think there may be exactly one bit of room available that's sort of later learning since 7606 was done that gives us some option to do at least one level of revision, which is if your implementation is guaranteed to only do one LRI per update, you completely break packing. It's possible for you to do a check to see, am I overflowing a given PDU boundary, and know that you have a single broken PDU. This still, as Anchor points out, leaves us in a case where we have lost information. We no longer know if the withdraw or the update that we're receiving is intended to update something we've already received. And in those circumstances, we'll be proceeding and leaving the session up as broken. And this was one of the things that terrified people. We don't want to do this especially for internet, but as we've discussed over the years, BGP is used for things besides internet these days. If this is your data center, maybe proceeding in a partially broken state makes more sense. So my recommendation to you is, it's okay to discuss this point, potentially discuss that there is some availability procedure for single NLRI to allow us to proceed in a broken fashion, and that this may make sense for some address families, but not like the internet use cases. An example of that is like the long-lived graceful restart feature. We put that out of scope for internet routes as part of the work that we did there.
Okay, thank you, Jeff. Thank you for your comments. Yeah, yes. As I think that for the about the error that across the PTU, I think this is no problem because even though we want to do best effort to pass the packet, but we still will. So we still will follow the basic foundation about the BGP's rule. So I think it is whether we will do it or not, we may not opposite the BGP's rules. And for the others, we just in our proposal that we just want to want to reduce the impact of the PGP, the error handling, because now although there are some nice dynamic capabilities, multi-session mechanisms to can help reduce this, but this is not implementation at the network now. So we just want to do as our best to prevent the BGP's neighbors reset, so this can make the networks more stability. Yeah.
Right. This is very much a discussion about operational safety. This is partially the discussion that is happening in the chat. And the original choice that we made was this is never safe. What we have seen over the course of the years since that, again, using long-lived graceful restart as the example, if it's your network and it's strictly your routes, leaving a session up until you can go through a maintenance procedure may make better sense. Leaving this in general internet means that you may be leaving black holes in the internet as a whole, and we already have a number of bugs that cause that. So we can continue that discussion on the mailing list.
Okay, thank you.
Thank you. And I'll add my comments. This is Keyur Patel, ARCIS as a working group member. I will tell you that everything that NK and Jeff said holds up, so I'm not going to repeat that. But one very interesting thing when we wrote enhance or revise error handling draft was there is no definite way to say after next stop length error that the prefixes in MP reach are not corrupted. So if you have a length error of 00, or if you have a length error of something, some crazy length error that's shown in, and it's an IPv6 session, just plain old, it's very hard to figure out that you're seeing a corruption on the stream or not. At that point, your best bet is to reset the session. That also goes with the fact that if the update message is carrying one single prefix only, because you have to wait for the next message to be parsed and figure out if the message is corrupted or not, or are you going to see the marker even right? So I think there are lots and lots of cases where you can't make it can't be guaranteed, like NK said, and you're going to hit that roadblock when you start solving some of these issues. I'll also post my comments on the mailing list, yeah? But thank you so much for the proposal.
Okay, with your comments. Thank you.
And we have Kwan, who's going to talk about the flow specifications for the DevNet flow mapping. Kwan.
Yeah, thank you. Thank you, Jeff. Do you hear me?
Yes, I can hear you. And I'm Keyur, but Jeff can hear you as well. Thank you.
Yes, thank you. I would like to introduce the BGP flow specification for Datlet flow mapping. Next slide, please. This slide listed order of things related to TSN data plane, including data plane framework, IPO over TSN, MPLS over TSN, and TSN VPN over MPLS. So in the figure shown, the datalet may provide the deterministic surface for the TSN end system, and the datalet IP and the MPLS flows may be carried over TSN subnetworks. So the flow mapping for TSN and datalet should be supported at the boundary nodes. Next slide, please. So regarding the data plane, there are two parts of requirements for the flow mapping. First is the primary requirements of the controller plane for the TSN and the datalet flow mapping. The mapping between TSN streams and the datalet flows is required for the service proxy function at datalet edge nodes, and the mapping table can be configured and maintained in the control plane. Second is the aggregation of datalet flows 1-to-1 and N-to-1 mapping must be supported. For example, aggregating multiple TSN streams in a single datalet should be supported. So this document proposes extensions in control plane to BGP flow specification for the flow mapping by using the traffic filtering rules to identify the packet and using the associated action to map the packet to the related surface. Next slide, please. So based on the requirements, this is the BGP FS extensions for TSN stream mapping to that. The string identification functions are defined in HV, and based on the existing filtering rules, this document just proposes a new type called mic surface data unit. It is an extension for L2 components flow spec type for TSN traffic filtering in mask and match stream identification. And for traffic action of TSN strings, the action is to accept the TSN strings matches the rule and map the strings to the testnet flow. So this document also proposed the sequence action extended community. Next slide, please. And for testnet flow mapping to TSN string, this document also DCW type in L string components for testnet MPLS flows. The extended action for testnet traffic filtering is to accept the testnet flows and match the rule and map the flow to the TSN strings. So this document also proposed the TSN action extended community. And the TSN profile can be converted to the string related parameters and the requirements, including TSN string ID, string handle, sequence number, and the traffic scheduling information. Next slide, please. So this is the BPFS extension for TSN and the testnet mapping. This draft has been presented in testnet yesterday. We get feedback from testnet and confirmed that this part of work is necessary. And thanks the suggestions from Jeff, we would like to present in IDR to get more feedbacks about the extensions of the BGP flow spec. So any comment and discussion are very welcome. Thank you.
Jeff, you have the mic.
Thank you, Kater. And Kwan, thank you for bringing this work also to IDR's attention. As you're discussing, FlowSpec is interesting work that is not only happening in IDR, but is getting leveraged in multiple working groups, including DetNet, PCE, and elsewhere. A piece of work that is challenging that has come out as part of RFC 8955, as we updated FlowSpec version 1, is we understand that it's not safe in current circumstances to extend FlowSpec with new capabilities like what is inside of your draft. So part of the work that IDR is discussing that you saw earlier today is that we are doing a FlowSpec version 2, and we would like to invite you to contribute work there as well. If you have not worked with Donald already, certainly he would be happy to look at this not only because of his FlowSpec v2 work, but also the overlap of this potentially with the L2 VPN work.
Okay, thank you. So we will update the extensions based on the FlowSpec version 2 last version. Thanks.
Thank you. Any more questions for Kwan? Thank you, Kwan. Folks, that was our last presentation in today's session. Thank you all for attending. If there are no more questions, we'll see you at next IETF. Thank you, folks.
Hopefully see you all in person next time.
Thank you.